Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Hadi bin Iramat Nilai Yusud. My number matric is 25DDT19F1056. So today I will explain about my assessment practical task 3 set A. So the CLO1 reproduce various techniques using various tools and technologies effectively to protect the given network from attack and threats. So this is the topology that we must build. And then the objective, part 1, configure basic device setting. Part 2, configure a site-to-site VPN using Cisco iOS. The required resources is packet tracer 8.002, packet tracer file lab 41B, configure site-to-site VPN using CLI. Part 1, configure basic device setting. Cable the network as shown in the topology. Configure basic setting for each router and disable the DNS lookup. So we go to the topology. So this is a topology that we must build, and this is a topology that I already built but not configured yet. And for router, we use 3 router, and the model is 1941. And for switches, I use 2 switches, and the model is 2960. For devices, I use 1 server and 1 PC. For cable, I use DCE for router. For router to switch, I use copper straight through, and switches to devices, I use copper straight through. And the port for R1 to R2, I use S00, S00. For R1, R2 to R3, I use S001 and S001. To use port S00, we must to go to the physical or router and go to the HWIC and put the port. Now we go to the next question. We must to configure the basic configuration on the router. So we go to the router, go to the CLI, no, and enable, and config T, hostname R1, and this is a hostname for R1. And then we change the name for R2, go to CLI, no, and enable conf T hostname R2, and do the same thing on R3. Now we must to configure we must to put the IP address for each router, and put the interface first. Interface for R1 that R1 use is G0/1 and S00. Now we put for G01 first. IP address, and this is the IP address for G0/1, and we must put the subnet mask also. Enter, and no shut. Exit, and put for S0/0/0. Enter, and this is the IP address for interface S0/0, and it's the subnet mask for S0/0. No shut. Now do the same thing on R2, like R1 interface that R2 use is S00 and S001. We put for S0 first. Enter and put the IP address. The subnet mask. Enter. No shut. For S0/1. Put the IP address. No shut. Now we go for R3. And R3 use G0/1 and S00/1. No shut. And second, we put for S00/1 for R3. Now, as we can see on this topology, the cable already green, and which means the router already connected because we already put the IP address for each router. And then we go to the next question. Now we must to disable DNS lookup. So for DNS lookup, we put for all router. Put the command no IP domain lookup. Also on this router. Okay, now we continue for part 2. Part 2, configure OSPF routing, PC host IP setting and verify the connection. So part 1, configure the OSPF routing protocol on R1, R2 and R3. So for OSPF configuration, we must put to all these three router 1, router 2 and router 3. So this is the command that I already write on Notepad. So I will explain for OSPF configuration. So first we must put the router OSPF 101, which means this is the process ID to differentiate between them. And then this we must put the network number, which means we can use any particular host IP address or network IP address. So next, this is the wildcard mask used with the network ID to filter the interface. And then this area that we must use for to same with all network. So for easily to you to see the what IP that you want to use to OSPF, we just put show IP route connected. So this is the IP that you must use to configure the OSPF on R1. So we just put this command to R1. Enter. And then we go to the R2. Now first we must to see the IP route like R1. Do show IP route connected. So this is the IP route connected that we must use to R2 like this command. And then for last we must to configure for R3. So basically we can use the OSPF already done process for R2. So we will get the process 101 and we are successfully downloading. So now we go to R3 and configure OSPF on R3. Okay. So we can see the process already done on R3. Now we continue for next step for part 2. We must to configure PC host IP setting. So configure a static IP address, subnet mask and default gateway for PCA as shown in the IP address table. So this is my address table. So for PCA, we must to put the IP address, subnet mask, default gateway. So we go to the PCA, which means the server. Go to the IP configuration and put this IP address, subnet mask and default gateway to the IP configuration. So this is the subnet mask and this is the default gateway. Next, we configure a static IP address, subnet mask and default gateway for PCC as shown in the IP address table. So we go to the PCC, go to IP configuration and go to this IP address table and put the on IP configuration. And put the default gateway. Okay, now we go to the third step, verify basic network connectivity. So we must to ping from R1 to R3 at 0/1 interface at IP address. So we go to the R1, go to the CLI and enable. Sorry, and ping from R1 to R3. So we go to the address table, put this command and ping. As you can see, it's successful. Next, we go to the PC, from PCA to PCC. So we go to the PCA, go to desktop and go to command prompt and pin, go to the table, there is a table, put the IP address from PCC and pin. As you can see, it also successful. So we already done for this step. Now we continue for next three steps. So next three steps, we must to configure and encrypt password, configure the password and configure as a disable. So before we go to the all three steps, we must to upgrade our three router version because the command that I use cannot support the command. So we must go to the R1 and show the version. As you can see, this router is the old version. So we must to upgrade this version. So the command is copy tftp flash. Okay. Next, we will get the question. So we must to address or name or remote host. So we must put the server address because the server address can help to upgrade this all router. So we put the network address that we use is 10.21.1.2. Okay. And then we must to put the source file name. So the source file name is this. So this command, so this iOS file I get from the router. So we just take from router. Okay. And then we enter again. And then as we can see, it will be successful. After that, we must to boot the upgrade. And then we must to reload. We must to exit. Sorry. And then we must to copy run config to save the file that we upgrade. Okay. And now we must to reload to make the upgrade to our router. So as you can see, it's already successful. Okay. Now we must to do now we must to put this command to all these two router. Okay, I already agreed to all these three router. Now I will continue my presentation for these three steps. So we continue for first step for configure and encrypt password. So password in instance are set to a minimum of 10 characters, but are relatively simple for the benefit of performing the lab. More complex passwords are recommended in the production level. So we must configure the same setting for R1 and R3. To configure a minimum password length, use the security password command to set a minimum password length of 10 characters. So we go to the G0/1, which means R1, and then we put enable. then we go to our PT and then put this command security password in dash lamp 10. Okay. And then we must configure the enable secret password on the router with the password of Cisco 12345. And then we put this command enable algorithm dash type script secret Cisco 12345. Enter. After that, we must create a local admin001 account using admin01 password for the password. So we put the command is username admin01 algorithm dash type script secret admin01 pass. Okay. Now we continue for next step is configure the console line. So for console line, we must configure the console to use the local database for login. For additional security, configure the line to log out after 5 minutes of inactivity. So we put the command is line console 0. Oh, sorry. And then put the login local exec dash startup 50 and then login sequence. Okay. After that, we go to the next step is configure SSH support. So we must to configure a domain name. So the domain name that we set is IP domain dash name ccna security.com. Next, we must to configure the RSA key with the 1024 for the number module bits. So the command is crypto key generate RSA general dash key modulus 1024. Okay. And now, as you can see, it already successful. Now we continue for the next step is we must issue the command to force the use of SSH version 2. So we just put the IP SSH version 2 on this router, and then we must configure VTY line on R1 and R3 to use the local database for login. So remote access to the router should only be allowed using SSH. So we must configure the line VTY 04. Enter. Oh, sorry. And then we put the login local, enter, and exit. Timeout. 50. Enter. So next we must to transport input SSH. Enter. Oh. Last step, we must to save the basic running configuration for all three routers. So the command is copy. Sorry, before we put the configuration config, we must to exit from this part config line. We just click Ctrl Z and put the command copy running dash config, enter, and startup dash config, enter. Now enter. Now the configuration that we put is already saved. Now we must to put this all command on R3. Now we continue for part 3. Configure IP set VPN setting on R1 and R3. Verify connectivity from R1 LAN to R3 LAN. So we go to R1. After that, we must to ping from R1 to R3. So this is the IP address for R3. And ping it. As you can see, it's already successful. Now we go to next question, enable IKE policy on R1 and R3. Now we use the lab. Configure IP set VPN setting on R1 and R3. Step 1, enable IKE policy on R1 and R3. IP set is an open framework that allows for exchange of security protocol as new technology and encryption algorithm as a key developed. So there are two central configuration elements in the implementation of an IPset VPN: implement internal key exchange (AKE), implement IPset parameter. So now we must to enable for IPset for function. IKEs are enabled by default on iOS image with cryptographic feature set. If it's disabled, you can enable it with a crypto ICKMP enable command. So we use this command crypto ICKMP. After that, we must to put to R3 also. After that, we put crypto ICKMP enable on R3. Now we continue for next question. We must to establish an ISAKMP policy and view the available option. So we must to allow IKE phase 1 negotiation. You must to create an ICKMP policy and configure a per application for the ICKMP policy. ICKMP policy define the authentication and the encryption algorithm and the hash function used to send control traffic between the two VPN endpoints. So issue the crypto ICKMP policy number global configuration mode command on R1 for policy 10. So we must to go to R1 and put this command crypto ISAKMP policy 10. After that, we must to view the various IKE parameters available using Cisco iOS help. So just put the question mark. So as you can see, this is the Cisco iOS help IKE parameter. Now we go to the next step. Step 2, configure the IKE phase 1 ICKMP policy on R1 and R3. So for this command, we must to configure SKMP policy with a priority of 10. Use a per share key as authentication type AES256 and for the encryption algorithm, SHA as the hash algorithm, and the diffie element group we use 5 key exchange, and then we give the policy lifetime of 3600 seconds, which means 1 hour. So I already put this command on this notepad. We just copy and paste to this router. So we already configure on R1, and then we go to the R3 and do the same thing at R3 like R1. Now we go to the next step. We must to verify the IKE policy with the show crypto IC KMP policy command. So we just close the router 3. We check R1 first. We just put the command show crypto ISAKMP policy. Okay. Now we can see the crypto already configured, and this is the policy of crypto and IKE. And then we just go to the next step. Step 3, configure per share key. Because this must to configure, the per share key are used as the authentication method in the IKE policy. A key must be configured on each router that point to other VPN endpoint. This key must be meshed of authentication to be successful. The global configuration of crypto ICKMP key string address IP address command is used to enter per share key. Use the IP address of the remote peer, which is the remote interface that the peer will use to route traffic to the local router. So we just put this command crypto. Now we continue for next part. We must to configure the per share key. So configure per share key. Because per share key are used as the authentication policy, a key must be configured on each router VPN endpoint. So we must to put on R1 and R3. So we go to R1 and then we put this command crypto ISKMP key Cisco and the addresses. Okay. Now we must to put this configuration on R3. So we must to configure the per share key Cisco 123 on router R3. The command for R3 point to the R1. So conft and put this command. The same command or the same command right R1, but we change the addresses. We use the addresses S00 from R1. Okay. Now we go to do the next step. Step 4, configure the IP set, transform set, and lifetime. The IP set transform set is the another crypto configuration parameter that router negotiate to from a security association. To create an IP set transform set, use a crypto IP set transform set tag command where tag is a name configured by the administrator. So use a question mark to see which parameter are available. So we go to R1 first. Put this command crypto IP set transform dash set R1 to R3. Question mark. So this is the IP set transform. Set is another crypto configuration parameter that a router negotiate to form a security association. So next, we go to on R1 and R3. Create a transform with the R1, R3 and use an ECMP transform with an AES256 capture with the ESP and SHA hash function. So crypto IP set transform set 50 ESP dash AES 256 ESP dash SHA dash HMAC. ESP dash AES 256 ESP dash SHA dash HMAC. And then we must to put on R3. Crypto IP set transform dash set 50 ESP dash AES 256 ESP dash SHA dash HAMC. Enter and exit. So we also can change the IP set security association lifetime from the default of 3600 seconds on R1 and R3. Set the IP set security association lifetime to 30 minutes or 1800 seconds. So put on R1 and R3. Crypto IP set security dash association lifetime second. Oh, sorry. And then we put to R3. This. Enter. Now we continue for next step. Step 5. Define interesting traffic. To make use the IP set encryption with the VPN, it is necessary to define extended access list to tell the router which the traffic to encrypt. A packet that is permitted by access list used to defining IP set traffic is encrypted if the IP set session is configured correctly. So now we must to configure the IP set VPN interesting traffic SCL on R1. So now we go to R1, go to LI. Now we put this command on R1 for IPsec VPN interesting traffic SCL. So we just go to config T and put this command access list 101 permit IP. So put this command on this R1. This enter. Now we must to configure on R3. 50 and then we put this command on R3. So this IP address I get from G0/1 on on R1, and this is the IP address from G0/1 from R3. And then for R3, I get the IP address from G0/1 from R3, and this is the IP address from G0/1 R1. Now we must to save first. Now we go to the next step. Step 6, create and apply a crypto map. So we must do crypto map as a site traffic the mesh and access list to appear and various IKE and IPsec setting. After the crypto map is created, it can be applied to one or more interface. The interface that is applied to should be the one facing the IPsec peer. So first we must create the crypto map on R1, name is CMAP, and use 10 as the sequence number. A message display after the command issue. So now we must to put this command on R1. Go to R1 and put this command crypto map CMAP 10 IPsec dash is AKMP. Enter. Now we can get the note. This is a new crypto map will remain disabled until appear and valid access list have been configured. So now we go to the next part. Use the mesh address access list command to specify which access list define which traffic to encrypt. So we must to put this command on R1 mesh address 101. Enter. And then we must to view the list of possible set command that you can do with the crypto map. So we must to put the command set and question mark. So we can see the possible set that we use, and the notes this new crypto map will remain disabled until appear. Oh, sorry. So this is what we configure on crypto. So we allow encryption description peer, and then we specify PFS setting, security association parameter, and specify list of transform set in priority order. Now we continue for D, setting of PER IP or SNAME is required. So set it to R3, remove VPN endpoint interface using the following command. So now we must to go to R1, put set PER, and the IP address I get from R3 as 00/1. And we just copy it and put to R1. Enter. Now we go to E, use the set transform set track command to hard code the transform set to be used with this PER. Set the perfect forwarding secrecy type using the set PFS type command and modify the default IPsec security association lifetime with the set security association lifetime second. Now, before we go to this command, we must to put this command. We must to exit from this part and go to config T and put the crypto IPsec transform Now we can get so many IPsec transform. So we just put this is AES, ESP to ESP to AES, copy and put on the back from this command and enter. Now we go to this command back. We go to this command back. Now we must to put this command Now we already configure the the PR use. So we exit. Now we must to create mirror matching crypto map on R3. Now continue F. Create a mirror one matching crypto map on R3. Before we put this command, we must to put the same thing like R1. We must to put crypto IP set transform set R1 to R3. So copy this command and paste to R3. So as we can see, we must to put the AES cheaper on this command. So copy this command then paste it and enter. Now we must to continue to put this command crypto map cmap 10 IP set IS KMP. Paste, enter. Now we must to mesh address 101, set peer and put the IP address from this S0/0Z0 from R1 and set PFS group file, set transform set R1 to R3, set security association lifetime second 900. Now we must to copy and paste. As you can see, we already successful to create a mirror matching crypto map on R3. Now we go to G, apply the crypto maps to the appropriate interface on R1 and R3. So we go to R1 and config and put the interface G0/0/1. And then put the crypto map cmap. Okay, we done and end. After that, we must to put this command on R3 also, exit and interface G0/0/1 and enter. Sorry. And put the crypto map cmap and enter. Now we already on the crypto maps to the appropriate interface. So we just end this session. So that we must to copy running config to all this router first to save the configuration. Now we go to the next part is part 4, verify the site-to-site IPsec VPN configuration. So we must to verify the IPsec configuration on R1 and R3. So we go to step 7. Previously you use a show crypto ISKMP policy to display the configured ISKMP policy on the router. So this command will display the configured IPsec policy in the form of the transform set. So we go to R1 and verify it. So crypto IPsec transform dash set. Now as we can see, the output same like this diagram, as you can see. Now we put this verify on R3. Show crypto IPsec transform the set. Okay, we already done it. Now we go to A. Use a crypto map command to display the crypto map that will be applied to the router. So we go to R1, show crypto map. So we can see the command display the crypto map that we apply the router. So this is from R1, and we go to R3. So for R3, we also get the output from the crypto map that we configure for R3. Now for last part 5, verify the IPsec VPN operation. We must to display ISAKMP security association, display IPsec security association, and generate some uninteresting test traffic and observe the result. And then we must to generate some interesting test traffic and observe the result. So for the part, we must to display ISKMP security association first. So to show SKMP security association, we must to put the command show crypto SKMP SA. Command reveal the no IKE SA exists yet. When interesting traffic is sent, the command output will change. So we go to the R1 and put the command show crypto ISA KMP. So crypto ISA KMP SA. So this is the command that reveal that no IKESA exists yet. So next we continue for next we must to display IPsec security association. So we go to R1, we put this command show crypto IPsec SA. Enter. So as we can see, this command show the unused SA between R1 and R3. So this is the all IP that unused from R1 between R1 and R3. Now we continue for the last step for part 5. We must generate some interesting test traffic and observe the result. So use an extended ping from R1 to R3 interface IP address, and then we must extended ping allow you to control the source address of the packet. Respond as shown in the following example. So we must ping from PCA to PCC. Go to the command prompt and ping it. As you can see, PCA to PCC is successful. Now we must to ping from PCA to PCC and then issue the show crypto IPsec SA command. So we already ping PCA to PCC. Now we must to go to R1 and show crypto IPsec SA. So this is a show crypto IP set after we ping from PCA to PCC. Now that's all for me for PT3. Thank you.